Good morning, everybody. It is Tuesday. Guys, we only have 2 weeks left. Really, 2 weeks, because the last couple of days, all I'm going to do is be bothering you to get your stuff in. So, that's it. We can do this. One more chapter. We're going to do our last chapter of trigonometry, which is the most important chapter of all. Okay, so first of all, right off the bat, if you have not got chapter 8 done, get it done. And forgive me, I'm still correcting some of these because I did take a little vacation because it was, a 3-day holiday. So I'm still correcting some of these, but get it in. If you guys have not got chapter 8 in, get it in. Otherwise, I'm going to make you do it over the summer, okay? So let's take a look. First of all, today we're going to talk about Pythagoras theorem, which everybody should know about Pythagoras theorem. That old a squared plus b squared equals c squared Pythagoras theorem. A squared plus b squared equals c squared, right? Well, that's silly. Let's instead take a look at our journal. I'll show you why I think it's silly. Okay, so let's take a look at our journal. Here's a right triangle. So first of all, it only works on a right triangle, period. If it's not a right triangle, then the Pythagoras theorem will not work, okay? Sometimes I like to rewrite the Pythagoras theorem. Instead of a squared plus b squared equals c squared, if I look at a right triangle, what I'm going to do is rename these, because sometimes I make triangles that look like this. This is my favorite right triangle right here. I call it the PIG. I mean, why not? You can call a triangle anything you want. It doesn't have to be A, B, and C. It could be triangle, right? Right triangle, C, A, T, right? So the a squared plus b squared equals c squared is only if the triangle is triangle A, B, and C. So, but you can name it anything you want. So here's what we're going to do. In a right triangle, okay? I want you to take a look in a right triangle, okay? Any right triangle. These two sides are called legs. They are. This is a funny name, but they're called legs. I know there's sides, but they're the legs. So the legs are the two sides that make up the right triangle. Then the third side, the longest side opposite 90, is always called the hypotenuse. Hopefully you've learned this in middle school, okay? So if it is a right triangle, then we've got the two legs that make up the right angle and the hypotenuse. So instead of a squared plus b squared equals c squared, I'm just going to rewrite it as length of the leg squared plus the length of the other leg squared will always equal the hypotenuse squared, or the longest leg, okay, the longest length, okay? So that's basically Pythagoras theorem. In our journal, we get what we call our perfect triples, okay? If we were to go, and I'll show you on the calculator, let's see, here's my calculator. If we were to go 3 squared plus 4 squared, what does that equal? All right, well, take a look. What's 3 squared plus 4 squared? Boom. 25. That does equal 5 squared, okay? 5, 12, 13. That's a perfect triple, okay? Now, not all of these are going to be perfect triples. 8, 15, 17. That's a perfect triple also. 7, 24, 25. That's a perfect triple. The reason we call them perfect triple is because these are nice numbers. These are all whole numbers. Nice numbers, whole numbers. Nice 7, 24, 25. Most of the time, I'll give you an example. Most of the time they don't turn out so nice. Let's say this side is 4 and this is 7, okay? If I were to use Pythagoras theorem on this, I would go 4 squared plus 7 squared equals the hypotenuse squared. Let's call it h squared, okay? And then I'd use my calculator. You guys have done this before. I'm sure you have. If you haven't, I'd be amazed. I take my calculator, I go 4 squared plus 7 squared, and I get an answer of 65. Well, then I'd have to take the square root of 65, and that's not a very nice number. It's a decimal number. 8.06, okay? So here's the trick. Most of our triangles will have decimal answers. 8.06 about. However, there are these 4 really nice ones that always work really well, okay? And math teachers, me too, like to use these numbers because they're not messy numbers, okay? But most of them are going to be numbers like this, okay? So let's keep going. So hopefully you guys know how to use Pythagoras theorem, but let's take a look. Now, the inequality theorem basically says this. If, now that doesn't look like a right triangle. No way, that's an acute triangle. It's an acute triangle because all the angles are less than 90. Well, if a squared plus b squared is less than c squared, then it's going to be an acute triangle, okay? Example, right? Example. Let's take a look at a triangle that looks like this. Let's say this is 4, and let's say this is 5, and let's say this side is 6, okay? Is it a right triangle? It doesn't look like it. Right triangle, right triangle, doesn't look like it, but we can prove it. We can prove it's acute because I can say, well, 4 squared plus 5 squared, does that equal 6 squared? Well, I don't know. 4 squared plus 5 squared, let's see what that equals 41. Is 41 equal to 36? No. So, in this case, if a squared plus b squared is bigger than that, then what I made is, I didn't make a right triangle at all. I made an obtuse one, didn't I? I made one of these. Okay, there you go. Let's see if I can make one of these. So in this case, I actually drew it wrong. It probably would have looked more like this. I used my ruler, I could probably draw it correctly. Hold on. Totally drew it wrong. There's 4. There's my 5. I should have drawn a scale. 6. Let's see. 4. And then 6. Yeah, look at that. It's more like an obtuse triangle, okay? And the other, which is one I should have drawn. Let's see if I can do this one better. I'm going to make one up. Well, let me just draw one so we prove it. Let's go 3. Let's go 2. And what's this one going to be? Maybe 2.5. Oh, that's pretty close. 2, 3, 2.5. 2 squared plus 3 squared. Does that equal 2.5 squared? I don't know. 2 squared plus 3 squared. Okay, what's that equal? Didn't like that. Didn't like that. Okay, 2 squared plus 3 squared is 13. And what's 2.5 squared is 6.25. So these two are bigger, so this one's definitely got to be an acute. Okay? Alright, moving on. So, I have some basic notes I want to look at. Should be an easy assignment for us. So, example, let's take a look at example 3. Okay? Find the value of x. Well, there's no a, b, and c. You know? A squared plus b squared equals c squared, but there are legs. You see, if we can't always name our triangles a, b, and c, but I have leg, leg, hypotenuse, so I can go x squared plus 20 squared equals 29 squared, right? Pythagoras theorem. This side plus this side squared plus this side squared always equals the longest, that's my longest, or my hypotenuse squared, okay? So I'd have x squared plus 400 equals what's 29 squared is 841 minus 400, right? Minus 400. Got x squared equals, what's that? 441. Take the square root of both sides. You guys know how to do this, I'm sure. What is that? 221, I think so. Square root of 441. Yeah, 21. There it is. So this is x equals 21, which means this is a perfect triple because all three of these numbers are nice numbers, whole numbers. 21, 20, 29. That's a perfect triple, okay? They don't always work out that way. Sometimes you get ugly numbers. So for instance, in this example right here, if you did x squared plus 12 squared equals 14 squared, right? Now, one way to quicken this up that I like is rewrite x squared is equal to 14 squared minus 12 squared. Because I just, just trying to make this a little easier myself. I just brought the 12 over and subtracted it, 12 squared. And then I can let my calculator do the work, right? I can just go as 14 squared, subtract 12 squared, and I get an answer of 52. So I get really x squared equals 52. And then again, square root, all right? And the square root of 52 is, and we can always go round to the nearest tenth. Nearest tenth is fine, square root of 52. And I get an answer of about, oh, I didn't like that either. I'll fix that. Sorry, guys. Delete that. I get an answer about 7.2, okay? Approximately 7.2. So this is not a perfect triple because 7.2 is not a nice whole number, okay? Now, tell whether or not it's a right triangle. How do I know if it's a right triangle? Well, 3 squared. Doesn't say, does it? We don't know. Does 3 squared plus 7 squared equal the square root of 57 squared? I don't know. Let's find out. Okay. 9 plus 49. Square root of 57 squared is square root of 57 squared. Cancel square root is just 57. 9 plus 49. I think that's 58. 9 plus 9. And I get 58. Does 58 equal 59, 57? No, so it's not a right triangle, okay? That's easy to prove, okay? All right, I got maybe one more problem to do. So these, if this is going to be a right triangle, is 5 squared plus 7 squared equal to 8 squared. I think this is bigger, which means this one's be acute. Okay, I'll let you figure that out, okay? And this opposite, this is 2 squared plus 10 squared equal to 11 squared. I'll let you figure that out. Okay, so let's do number 11. Diagram, let's do a story problem. Because people use the Pythagorean theorem. This is like the most used math. Builders use it all the time, okay? Here's an example. Okay, the diagram shows the design of a house roof. 24, 24, the height, right? Okay. And we have, what's the approximate height of the house? There's the approximate width of this house right here. Okay, so you get 24, 24, right? So first of all, you got a right triangle here. So we can use Pythagorean theorem to get this. So before we do anything, take a look. I'll highlight it. You see a red triangle here? I know you do. So take and look at just the right triangle and turn it around like this. Hey, there's a right triangle, okay? So let's go my a squared plus b squared equals w squared, right? And I'll just use my calculator, so I'll go 24 squared plus 24 squared, okay? And I'll take the square root of that, right? Hopefully I'm not going too fast. Hopefully this makes sense. Square root of that answer, and the width of the house is about 33.9, okay? So the width of the house, 33.9 feet, okay? What is approximate height? Okay, so now let me go back and make a second triangle, which I think you'll see. So the second triangle is going to be that triangle there. I know that this is going to be a 90-degree angle. I know this is 24, and I'll take half of my width, right? Half my width. So I'll go 33.9 divided by 2, and I get about a 16.97. And I can find the height of the house, okay? Again, I'll just use Pythagorean theorem. We'll go h squared plus 16.97 squared equals 24 squared. Okay, for me personally, to quicken this up, I'll just subtract this over here. I'll have h squared is equal to 24 squared minus 16.97 squared. And I'll let my calculator do the work. Okay, so I will go 24 squared, subtract that answer squared. Okay, and then I'll take h squared is equal to 288. Okay, and I'll square root that answer. And I'll get an answer of about 16. No, that doesn't. 24 minus 16.97. I get 16.97. Interesting. Okay. So there it is. That's a isosceles triangle. Got a 16.97. Huh. That's an isosceles triangle. So there it is. So homework for today, you guys. Homework. Page, I'll show it to you. Page 284. 1 through 9 all. Show your work, please. 284. There it is. Okay. Tell whether it find the missing side. If it's a perfect triple, then it's a whole number. Okay. 7, draw a picture. 8, 9, tell whether it's obtuse, acute, or right. And that's all I have for today. Okay, so I will talk to you tomorrow.